Hello everyone. In this session of CCNA series, we'll discuss about PoE or Power over Ethernet. Power over Ethernet or PoE is a revolutionary technology that integrates data and power on the same cable. As you can see, with non-PoE device, you need a power cable to power on the device and copper cable for network data. But with PoE, it allows devices to receive power in parallel to data over existing twisted pair Ethernet infrastructure without making any modifications in it. Let's try to understand this with an example. When you walk around any building and you see electrical power outlets everywhere. When finishing the interior of a building, electricians run electrical cables and install electrical outlets to any and every location that might need power, such as fridge, TV, PC, etc. As a network engineer, you might have thought that the electrician might have provided enough power to the wiring closets to power on the networking devices. PoE changes that thinking so that the responsibility to provide electrical power to some devices can fall to the network engineering team. The LAN switch connected to the cable can supply that power over the cable. Let's understand the terminologies used in PoE. With PoE, some device, typically a LAN switch, acts as a power sourcing equipment, also known as PSE. That is, the device that supplies DC power over the Ethernet UTP cable. A device that has the capability to be powered over the Ethernet cable rather than by some other power connector on the device is called powered device or PD. Why use PoE, or what are the advantages of using PoE? Let's start with time and cost savings. By reducing the time and expense of having electrical power cabling installed, network cables do not require a qualified electrician to fit them and can be located anywhere. The next advantage is flexibility. Without being tethered to an electrical outlet, devices such as IP cameras and wireless access points can be located wherever they are needed most and reposition easily if required. The next advantage is safety. PoE delivery is intelligent and designed to protect network equipment from overload, underpowering, or incorrect installation. The next advantage we have is reliability. PoE power comes from a central and universally compatible source rather than a collection of distributed wall adapters. It can be backed up by an uninterruptible power supply or a control to easily disable or reset devices. Next advantage we have is scalability. Having power available on the network means that the installation and distribution of network connection is simple and effective. Since it supplies DC power over the Ethernet cable, so the devices does not need an AC-DC converter. Let's look at the common devices that use power over Ethernet. Starting with VoIP phones. The original PoE application using PoE means phones have a single connection to a wall circuit and can be remotely powered down. IP cameras. PoE is now ubiquitous on network surveillance cameras, where it enables fast deployment and easy repositioning. Then we have wireless devices such as Wi-Fi access points and RFID readers, which are commonly PoE compatible to allow remote location away from the AC outlets and relocation following site surveys. Let's look at how PoE operates. Every electrical device can be harmed by receiving too much current into the device, which is why electricians install circuit breakers and why we use surge protectors. Applying power over Ethernet cable could have the same effect, harming the device on the other end. If the device does not support PoE, so PoE must have a process in place to determine if PoE is actually needed and for how much power. Before applying any potentially harmful power levels to the circuit, PoE standardized by the IEEE extends the same IEEE auto negotiation mechanisms. In fact, the mechanism needs to work before the PD has booted because the PD needs power before it can boot and initialize. By using this IEEE auto negotiation messages and watching for the return signal levels, PoE can determine whether the device on the end of the cable requires power. That is, it is a PD and how much power to supply. Let's start with the process. First, it checks whether to supply power on a PoE capable port unless negotiation identifies that the device needs power. If yes, then use Ethernet auto negotiation techniques, sending low power signals and monitoring the return signals to determine the PoE power class, which determines how much power to supply to the device. If the device is identified as a PD, supply the power per the power class, which allows the device to boot. Monitor for the changes to the power class both with auto negotiation and listening for CDP and LLDP messages from the PD. If the new power class is identified, adjust the power level per that class. The negotiation process results in the PD signaling how many watts of power they would like to receive from the PSE. That's it for this session. In my next session, I'll discuss about interface and cable issues.